Hi, everyone, and thanks for joining me today for episode 758 of People Behind the Science. Today, we are excited to be resharing our interview with Dr. Adam Gazzaley, originally released on November 2nd of 2015. Listeners, Adam's research focuses on aging and how different aspects of cognition, like memory and attention, can change over our lifespan. His team is working to develop new innovative tools, including engaging video games, to enhance brain function, improve cognition, and improve quality of life. And in our conversation, Adam talks more about his life and his research. So I hope you enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. I am thrilled to be here today with Dr. Adam Gazzaley. So, Adam, welcome to our show.
Thanks for having me.
Now, I'm excited to introduce you to our listeners, so I'm just going to dive right into our introduction here. Listeners, Adam is a professor of neurology, physiology, and psychiatry, as well as the founding director of the Neuroscience Imaging Center at the University of California, San Francisco. Adam is also co-founder and chief science advisor of Akili Interactive Labs, a company that is developing therapeutic video games. Now, listeners, Adam received his MD and Ph.D. in neuroscience at the Mount Sinai School of Medicine. He then completed his internship in medicine and clinical residency in neurology at the University of Pennsylvania, followed by postdoctoral training in cognitive neuroscience at UC Berkeley. Next, Adam joined the faculty where he is today at the University of California, San Francisco. And now, listeners, Adam has received a number of honors and awards during his career. We'll just list a few here today. He is the recipient of the Pfizer AFAR Innovations in Aging Award, the Ellison Foundation New Scholar Award in Aging, the Harold Brenner Pepinsky Early Career Award in Neurobehavioral Science, and the UCSF 150th Anniversary Alumni Excellence Award. Adam is also an elected member of the American Society for Clinical Investigation. And listeners, Adam is here with us today to tell us about his journey through life and science. So Adam, today we want to get to know you both as a scientist, but also as a person. So can you start off our interview by telling us what you like to do with your time when you're not doing science?
So when I'm not in the lab and doing science, I'm largely looking for quality time with friends, family. Socializing always has been a very important part of my life. It might include things like dinners, live music, camping, hiking, outdoors in general is always very exciting to me. So interacting with people that are not immersed in exactly the same type of activities that I am has always been very valuable.
That sounds wonderful. I like that you emphasize the people that you like to spend your time with. So are you a fan of hosting parties as well?
Yes, I do like to host parties. I've actually had a party in my loft for the last 7 years, once a month. It's called First Friday, and it's a really fun way to bring in a really diverse group of people and share my home. And so that's something that I do pretty regularly.
Well, that sounds wonderful. Great to hear about how you spend your time when you're not hard at work in the lab. But I know you've been keeping quite busy, Adam. So we want to hear about your science next. Can you tell us how you describe what you do to someone who might not be familiar with science or your field?
Yeah, so it's gotten easier as the research and development work that we do in the lab has become closer to people's daily lives and activities that they're familiar with. So the way I usually describe at least part of it, and it usually depends on what aspect of our research someone might be interested in. We do a lot of work on aging, and I have a lot of friends that are older, and so some of it might be a description of how we try to learn through our work, how the brain changes as we get older, and how cognition, such as memory and attention, change across our lifespan. But more than likely, when people are asking me about what I do, they probably already have an idea about the works that we do on video games and training and enhancement. So from that perspective, I would describe that we are developing new tools and try to be as innovative as we can in that domain, very frequently using customized video games to enhance how brains function and improve cognition and hopefully lead to better quality of life.
Very cool. Well, Adam, as a neuroscientist myself, I am excited to dive into your research as we go through the interview. But I want to talk here about motivation for a moment first. So I know there's so much to get done in a day as a scientist that sometimes it's hard to balance everything. So do you have a particular motivational quote or maybe a saying that you like to keep in your mind when you're going through a tough day?
One quote that constantly plays through my mind is that all of life is a celebration of life. And I find that concept inspirational to not only be waiting to celebrate that win that as a scientist might be a long time away, but that every little step of the way is worthy of celebration.
Certainly. Well, I think this is a really important thing to do as a scientist, to stop and celebrate these successes, but also just the general day-to-day, the excitement of going in to do science. So I like the approach. And now I'm curious next to hear, Adam, about some of the people who've had a big impact on you. I know as a scientist, you get to work with some phenomenal and inspirational people. So can you share with us some of these role models, some of these figures who've made an impact on your career?
I'd say my earliest science role model, at least science communication role model, was Carl Sagan. Probably not alone in that. He was certainly very inspirational to people from my generation that grew up watching Cosmos on TV. And so that was probably the first time I've thought about science and what it meant to be in the field. And then also what has stuck with me till today is how important it is to invest some of your time into scientific communication to the public. So that was certainly a role model and an inspiration to me that I return to frequently when I think about my own career now.
Definitely. And I know your research has received quite a bit of press. So do you channel some of these Carl Sagan moments when you're there in the media trying to communicate your science?
I certainly try to. It's a far call, perhaps, from some of the amazing public appearances and pieces that he did, but I certainly do try my best to communicate what we do in the lab or science in general, especially neuroscience, obviously, to people to make it exciting to them and accessible. And it's something that I'm constantly trying to get better at. So, yeah, I do try to channel that spirit at the very least.
Certainly. And I think it's easy to get excited about neuroscience. So in your fortunate position here. So
That's true. People do love the brain.
That's right. Well, Carl Sagan is a fantastic role model to have for this science communication perspective. But now, Adam, I want to look farther back and I want to hear about how your interest in science began. Is there a particular memory that you can think of where you really saw that spark ignite?
Well, I had pretty much wanted to be a scientist since I was, I guess, around 7 years old. I can't remember that time in great detail. I can tell you that I did not know any scientists at that time. My parents didn't come from that background, and actually the first person in my family to go to college. So I wasn't really exposed to a very academic environment, although academics were highly prized and valued in my family. But something in my early childhood triggered this desire to become a scientist. One of my earliest memories involved a water gun that I was using and squirting all of my parents' friends with. I was sort of a wild kid.
I like it.
Yeah, and I was having a good time and just amazed at how impressive this water gun was, and I was trying to figure out how it worked, and I had no idea how I was shooting water across the room. And I remember asking my dad about it, and maybe he was leading me down a path purposefully because it wasn't maybe the most accurate answer, but I asked him, who made this? How did this water gun come into existence? And he said, oh, scientists created that. And so I was like, wow, scientists. I want to be a scientist. And starting with that very sort of distorted beginning, I would constantly repeat that I wanted to be a scientist if anyone asked me what I wanted to be when I grew up. And then after a while, I started figuring out what it actually was. And maybe it was just stubbornness that had me repeating it for so many years before I knew what being a scientist was. So that's sort of how it began, and I never looked back.
You'd almost brainwashed yourself. I like it.
I think that's true.
Well, Adam, wonderful to hear about your beginning. So can you tell us then, what took you from this fascination with squirt guns to wanting to study the brain?
So I went from water guns to astronomy and the cosmos as an interest, probably because of Carl Sagan and his whole series on PBS. And It wasn't until I was an undergraduate, I was actually a biochemistry major, still searching for something that really inspired me. I quickly realized that what I conceived as a career in studying the cosmos was not as glamorous as I had pictured. And so at some point that dream disappeared, and biochemistry was an interest of mine. And then I was taking a class when I was an undergraduate. I think I might have been a junior. The class was called The History of the Future. It was actually a very cool class. It was one of the few humanities I took in my PAC biochemistry major. Mm-hmm. And what the class was basically talking about lessons from the past that help us envision a future. And this particular one was focusing on the brain and nanotechnology in the brain in particular. And I was just sitting there, and it was probably, even though I've taken psychology classes, for some reason, this particular class and how it was positioned so futuristically just struck me. And I, at that moment, knew that I wanted to study the brain. And I went straight to our library on campus and took out like 24 books on the brain.
Oh, wow.
And just started flipping through them and absorbing as much as I can. And that really is sort of what led me down that path of saying being a neuroscientist is the future that I want.
Well, very interesting to hear a little bit how you started on this pathway. But now, can you tell us what are some of these key moments along the way from this point on that brought you to where you are today at UCSF?
Let's see. First, I would like to say that what's been a constant message that I've gotten throughout my career, and one that I share as well, is that it's not always these big, dramatic, well-planned out events and moments that guide you in your life, but very frequently these things that seem incredibly random that just pop up like a water gun or some course that I was sitting in. And I think especially very motivated, highly goal-directed people feel often that those life inspirations come through like formal retreats and highly inspiring figures that guide you, but life is not always like that. It's sometimes these very random events that change your path. And that's happened to me not only in the formative periods of my life when I was first thinking about becoming a scientist and then later into neuroscience, but throughout my career as well. For example, when I was a graduate student at Mount Sinai, and I was meeting with my rotation advisor who became my Ph.D. advisor, John Morrison, and we were discussing projects. He just happened to have this opportunity to have brains of old non-human primates that we would have access to, and we can look for anything we wanted in their brains to understand aging by comparing them to younger brains. That was just a conversation in the hallway. He's like, I have this opportunity. I could take it or not. Would you be interested in picking this up as a rotation project? And I didn't ever think about aging. I was 22 years old.
Right.
And I was like, sure, that sounds interesting. Mm-hmm. So he's like, we could look at glutamate receptors. They're involved in memory. We could look at the hippocampus. We could come up with a really cool project to at least explore what might be different about these old brains. So I took that project, and I've been doing aging research now for 25 years. So
oh, wow.
People often think like I had a grandmother with Alzheimer's disease. It made me think about aging and cognition, and it really wasn't like that. It started just sort of randomly that I had passed him in the hallway. Maybe it would have went to a different grad student, that project. But in either case, I obviously grew a strong passion for the field and the topic, and it's really changed my whole life because my focus of my research for so long has been understanding the aging brain. So that was a unique, pivotal point.
Certainly. And I think a lot of scientists I have talked to have given some credit to serendipity in their pathways. And it sounds like a similar situation in your case where who knows where you might have been years ago if you had gone a different path. So very, very cool. Now, Adam, I know you are doing a lot of really exciting research in the laboratory right now. So I want to talk about one of these projects that you have on the table, and you can pick whichever one you're most excited about right now.
Okay, that's a tough one. We have a lot of projects in the lab. I would say at least 20. We have a big lab. And I feel like picking a favorite is like picking a favorite kid. Like people really feel very uncomfortable about doing that.
It is.
Yeah. So
it was a cruel question I've asked you.
I won't pick a favorite project, but I will pick a project that is fun and interesting and potentially very exciting. As I mentioned, we develop from scratch video games that we custom design and then build with professionals in the industry and large teams of postdocs and faculty that are in the lab. And then after development, which could take a couple of years, we advance to the validation stage where we do pretty deep dives into what changes in the brain and in terms of function and cognition from gameplay, from extended gameplay. And that's something that applies to probably close to a dozen projects in the lab, have that general overall goal and sort of pathway. So we have been developing a game for the last 2 years. This one is special. They're all special in their own way. This one is special because we developed it completely in-house with our own interactive media team and our own artists. So most of them are either contract work or we have a lot of philanthropy development help. This one was one that was born completely in-house. The game is called Body Brain Trainer. We usually call it BBT. And BBT took us 2 years to develop. It is now completed and in a research study. So BBT is a game that uses the Connect 2, which is part of the Xbox One gaming platform. And it is a game that challenges you both physically and cognitively in the same gaming experience. So you are given different challenges. The challenges are all in the domain of cognitive control, so working memory, sustained and selective attention, task switching, and multitasking are all part of what is demanded in the game. It's sort of a 3D game that you play, and while you respond to these challenges, you have to respond by using your whole body to touch different parts of the screen, essentially, but in the air since you're being captured. So the game advances. You play it in 4-minute intervals. It is incredibly exhausting. And so after each 4-minute interval, you get a 2-minute rest break and then back into the game. So one session of BBT takes an hour to play. So the game, like all the games that we develop in our lab, are adaptive, meaning that as you play, the game records your performance in real time and uses that information to scale the difficulty in a way that's appropriate to your abilities and also changes with you over time. BBT is no exception to that. All of the challenges, largely in response to your accuracy and your response time, are scaling to your difficulty. What makes BBT unique in another way is that we also record your heart rate using a heart rate monitor. And so during gameplay, your heart rate is being transmitted into the game engine, and the game is changing the physical challenge to hold you at a goal that we set based on a VO2 max that you do before you go into the experiment. So that's BBT. The hypothesis behind this experiment is that if you train cognitively, so if you're challenged cognitively, the learning curve on the different cognitive dimensions and even the outcomes will be accelerated if you are physically embodied in that training program. And that can happen just through the physical embodiment itself, and there's lots of reasons why we think that may be, and also because of the physical fitness demands of the task as well. And we know that physical exercise has benefits on brain health, which has been nicely documented in both animal models and humans. So we will test, and we have already started this study, to see if playing BBT in that dual mode, where it's both physical and cognitive, leads to stronger cognitive outcomes than playing that exact same game in cognitive mode, so essentially playing the game with a joystick, so just your eyeballs and fingers, versus playing a version of BBT where it's completely physical, has exactly the same physical demands and rewards and challenges as BBT, but there's no cognitive demands. So we can see if there is an interaction between physical and cognitive in terms of the outcome measures that we're looking at.
Well, Adam, this sounds fantastic, and it sounds like a really fun way to engage people in something that might be able to improve their performance. So did it start with you being interested in video games outside of the lab?
Yeah, I've always been interested in video games. I was a pretty big gamer when I was a kid. Playing Atari 800 is one of my earliest memories. Actually, I finished, a lot of people don't know that this game can be finished, but I finished the game Asteroids, which actually is finishable, apparently, after you have sat and not gone to the bathroom for 8 hours of continuous gameplay. After months of reaching a level where the entire board or the entire field screen is covered in asteroids, it actually says game over. So yeah, I was a pretty big game player when I was young. I played less during my 20s and 30s, but continue to play games outside of the lab now. I have to say most of the games that play outside of the lab are our games because we're constantly testing them, and now I'm actually playing 3 of the games all at the same time, which is part of a little challenge that I'm doing here. But yeah, I always enjoyed playing games.
Well, Adam, that is very impressive, I must say. We could have saved that for the success question, you finishing asteroids. That's
yeah, sure.
Quite impressive. Well, wonderful to hear about your research and your interest in video games that led into it. And I know we've talked so far about a lot of the exciting, fun aspects of your career as a scientist, but I think there are a lot of wonderful things about the career, but there are some frustrations, there are some struggles, there are some challenges that you face as a scientist going in every day. We like to highlight these so that aspiring scientists kind of know what they're getting into and that the public can have an appreciation of some of the challenges and failures that scientists encounter. So can you share one of your own stories, one of these dark days, one of these struggling, frustrating times, and tell us how you worked your way through it?
I think that there are always struggling times. We're fairly successful as a lab now, and we're big, and so we have lots of people we could rely on, and there's lots of safety nets since we have 6 faculty in the lab. But the reality is that we get papers rejected, we get grants rejected. It's just the nature of the beast, and this is not news to anyone that's doing science. It's always hard, and you don't really get to rest on laurels for very long, if at all. You're constantly having to defend your ideas, which is appropriate, but there's a very high rate of rejection in this business. So we're still constantly faced with those challenges. It's probably less interesting of a discussion because it's probably completely universal that everyone is frustrated by the challenges of funding, even getting papers accepted, especially if you shoot for very high-tier journals. It's just a really rough process, and we're not immune to it, certainly. There's also another challenge, and we've been pretty fortunate that a lot of our big hypotheses that we were testing on projects, and our projects take years because they're longitudinal, they take years to develop, and they cost lots of money, but they don't always end successfully. We have examples of projects and games and things that we were quite excited about, and then when you get the results back, they just don't really add up into the type of conclusion that might even be worth publishing at all, so not even just negative findings. It's really discouraging, especially if you have young scientists that are leading it, whether they be grad students or postdocs. But it is the nature of the beast that we are discovering things and not always inventing things. Although we do invent our games, we hopefully discover the changes they make. And there are times when we look at the results and we go back to the drawing board and repivot and start again. And it could take another couple of years. And so that is a really challenging part of being a scientist, is to know that even with the best intentions and the highest, most rigorous methodology and the most brilliant hypothesis, it doesn't mean that you will have a successful outcome to that study. And hopefully it happens few and far between, because it is quite a challenging period of recouping from that and reapplying, especially if there's a degree on the line and things of that nature. So we've had a couple of those over the last several years, and we have dozens of studies in the lab. So just probability alone would lead us to conclude that this will happen. It's just part of what the process is.
Absolutely. So to walk us through how you cope with these situations, say you get the bad news right now, today, you are looking at results and they are not good, they are not publishable. What do you do?
I usually just find a way of looking on the bright side, I would say. I mean, obviously it's disappointing, but there's always a way of learning from that experience that can help with the next shot at goal. So I'd say if that happens, then we would have like a full team meeting and debrief, maybe go out for a beer.
Right.
That's probably not an impossible outcome after something like that. Let it sit for a while and then re-strategize probably after a couple of days. Just let it sort of pass. Do a full debrief and try to figure out where the failure occurred. Like, why didn't we see what we expected as an outcome? Was it part of the experimental methodology? Was it part of the development if it was a game project? Was it a motivational issue? Were there lots of individual differences? And we learn a tremendous amount from our failures, probably more so than our successes in some way. So once you get over the disappointment of that type of outcome, I think it winds up being at least a mildly positive experience because it guides better research going forward.
Definitely. You got to find that silver lining somewhere. And I like this approach of really being systematic, taking it apart, looking at all the different elements that could have contributed to that failure and gleaning whatever lessons you can and moving on. I think that's a really good approach because you're absolutely right. These failures are going to happen no matter who you are, no matter what you're studying. So we don't just want to talk about your difficult times, Adam. I want you next to share with us a success story. This is your chance to brag here. So can you share with us a story that has a happy ending? And it can be either one of these big victories or a small win.
Well, we had a really big victory in 2013, so not that long ago. Our first video game project was a game called NeuroRacer that I had the idea for pretty early on and reached out to friends of mine at the video game company LucasArts, and we built it. Took a year to build, took 4 years to do the research study. It was a very high-risk study. It was very hard to get funded. Those days, this concept was a lot less familiar to funding agencies, and so it was a real challenge. But after pushing through all those hurdles and collecting all that data, we got an amazingly interesting series of results that we were able to put together to a story and then battle through the review process and wind up getting it accepted to Nature. And so that was published in Nature in September 2013. And then we're also able to put together a pretty fun image of a stylized version of the game, and that was accepted as the cover of the journal. We had a large team working on that. Like I said, it was 5 years from conception all the way through publication. So after that, wind up with the cover of Nature was a pretty big win for us and really exciting memory.
Congratulations, Adam, on this huge success. Listeners, for anyone out there who's not familiar with Nature, this is like the holy grail of science. Everyone is trying to get their papers published in either Nature or a science journal. So fantastic success there. So how did you guys celebrate?
We had a really big party.
Did you host it?
Yeah, I hosted at my loft, the Nature party, and we had this epic cake that looked like the cover of the journal. It was an impressive work in itself. Everyone that was involved in the study over the years, from our game developers and engineers and artists and all of the research associates, of which numbered, I think, at one point close to 50. It was a big, big project. We're all there. And so, yeah, it was a really exciting time. We had a big printout of the cover, and it was great. It's really important, as I said before, to celebrate all the wins along the way. But when you do have something like that, to really make sure that every single person that played a part in it feels that they're included in celebrating the event. So that's always been very important to me. And we do a lot of those. We just had our 10-year laboratory anniversary. And again, we had a big party at the loft where we brought in everyone from our history over the last 10 years, all the people that have worked here. So yeah, I find that really, really valuable for the team in general.
Well, I definitely agree with you here. I think you need to take every opportunity that you can to celebrate these successes in science, because sometimes you do go through dry spells where it's a little while before you feel another success. So
oh, for sure. Yeah.
Definitely important to celebrate. Well, great to hear about some of these things that you have done in your laboratory, these successes, these failures, these things that happen along your path as a scientist. But now I want to take a pause and talk about your life outside of science again. I love getting book recommendations from everybody that I talk to. So I am going to trouble you for one today, Adam. Can you share with us a book that you've read and really enjoyed? And this can be a science book or a non-science book.
Sure. I don't have an incredibly diverse reading sort of program here. I really almost completely read books about the future. So I guess that would fall in the science fiction genre. But even in there, I love reading about future scenarios, future technology. They can have rich characters and plots. I obviously value that. But I do like pushing my imagination into futuristic realms. So that's almost completely what I read when it comes to fiction. I try to read a little bit of fiction every day if I can. I've been on a good roll for a while now. The most impressive science fiction books that I've read over the last couple of years is a series by an author, Peter Hamilton, a British author, and he has a series known as the Void Trilogy, and it takes place in the distant future, and it is incredibly imaginative and fun and addicting. And so that's something that I will probably read again at some point.
Excellent recommendation. We will put the Void trilogy out on our website for our listeners to find. And you mentioned you have this fascination with the future and future technology. I'm curious, if you could have any piece of future technology right now, what would you want?
I'm really, really very excited about all the potential in the virtual reality and augmented reality domain. I visited pretty much every company that is developing these types of displays, as well as the other peripherals that are involved in that experience, to see what is coming in the future. So I have a pretty front row seat onto what the world will be seeing over the next 1 to 5 years. And so I would wish that was here at the highest level of what I've seen, and beyond that. And then I would take that and integrate it with a lot of the new advances in artificial intelligence, combining them together at a high level with the type of video game engines that we create, I think will have really, really powerful potential to impact brain function. And so that's a future that I am trying to run into as rapidly as I can, but I am held back by just the reality that it's not here yet, and we're still developing lots of hardware and software in those domains, but it will be here soon. It's not the distant future.
Gotcha. Well, wonderful to get a look into what you are looking forward to in terms of technology for the future. And I know we've talked about a lot of different aspects of your career as a scientist, and one that we really haven't touched on yet are the opportunities for travel. And this is one of the great things about the career. So can you think back now, Adam, to all the places you've been for science, and tell us about your favorite, and what was it about this place that just made it so special?
Well, I travel an excessive amount for science. I give a lot of talks. It's a big part of my career. I think last year was 74 talks.
Oh, wow.
So I travel a lot, and a lot of it is international. I have a talk coming up in Africa this year, which will be 6 continents of talks. So just after that, I just have to hit up Antarctica, and I got them all.
Yeah.
But favorite, I don't know what the favorite would be. I could tell you this year I had some very unique travel. I'll just pick a place. I started the year with a trip to give 2 talks in Saudi Arabia, and it was a very, very different place that I've ever been to. Jeddah was the city where I gave those talks, and it was really fun to step out of my comfort zone and into a place that was just incredibly culturally different than what I am used to. And to go there and be warmly greeted and have strong connections with the people that were hosting me, and to have really nice bonds with the audiences that I spoke to, just opened up my mind to a whole society that was unfamiliar to me. So I would put that on the high list of places that I visited this year, let's say.
Well, very cool. Very diplomatic answer. We won't ask you for any more favorites now. But very cool to hear about your experiences. And now we've talked a little bit about some of the people you've worked with in your science career over the years. And I think each group of scientists you work with, each lab, kind of has its own personality. And there's a lot of quirky traditions that spring up, or you just share wonderful memories with these people because you're working together, often for long hours. So can you share with us today, Adam, one of these stories of your own about a quirky tradition you experienced, or maybe one you have in your lab right now, or just a funny memory from science?
It's sort of easy in our lab because we have video games that we built or trying others all over the place. So we, unlike a lot of labs, have a lot of game time. I mean, I'm a fan of saying, look, while I'm out of town, make sure that you're all playing video games. So, it's not a standard type of place here. Playing games is like a required activity to be in this lab because it's so core to so much of what we do now. That's probably the most quirky part of our lab that makes it unique. And in lab competitions and things of that nature that are good-natured but pretty funny, you see different levels of abilities. We have a rhythm training game that really pulls out some fun skill level differences between people in a fun way. So, yeah, and I think there'll be a lot more as we go forward and get more into a lot of the motion capture games.
Definitely. And for some of this rhythm training work you're talking about now, is this the collaboration that you've had with Mickey Hart, the drummer from the Grateful Dead?
Yeah, so our game Rhythmicity was inspired by my friendship and our professional relationship with Mickey Hart, and now many other musicians have been involved in that project. So that was another, I guess that was like a little over a year of development. That game is pretty much done. We have a new game, even though there's a project lead and a research team and a development team, the entire lab participates in the beta testing and the refinement. So there's lots of different gaming competitions going on, and rhythmicity is one that is just coming off development now. So lots of rhythm game music playing going on.
So would you say you have a pretty good sense of rhythm? Are you pretty musical?
I don't think so. I would say it's okay. I think I've been training on rhythmicity now for a month, and it feels like it's getting better. I don't know. I'll be doing a diagnostic next week to see if my rhythm abilities have increased. I'm not a musician, but I listen to music constantly. Seeing live music is probably my biggest pastime. I like dancing. So I wouldn't say I have no rhythm, but now that I play the game and see people that are musicians play it, I realize sort of what I realized all along, that my rhythmic abilities could be a lot better. So that'll be really interesting to see next week how much I was able to improve it through our gameplay.
Very cool. Well, wonderful to hear about some of these traditions in your lab. And it sounds like you guys have a really fun environment. You work hard, but you have fun together too. And I think that's so important for a healthy and happy lab dynamic. And now I asked you a question earlier about technology and what sorts of things you were looking forward to in the future. And now I'm going to take away all the restrictions, Adam, and broaden the question a little bit here. So if things like funding and staff and technology and feasibility, most of the barriers that you face in science were not a problem, can you tell us today what research question you would want to tackle first?
I think the biggest research question I have that is a good distance into the future is how all of the different approaches that we have been developing in our lab to improve brain function, how they all work together. We're not trying to make a holy grail out of any single modality. I don't believe in that. I just don't think that we'll ever come up with any single intervention that's capable of impacting the brain in a really meaningful, sustainable way alone. But you have to work through each of the interventions alone against a placebo control to at least understand what its role is. If I could get rid of all feasibility and get rid of time demands and all of the development that's required, I would want to see how all of the things that we're building, from our video games to our cognitive BCI to our neurostimulation, all work together to refine brain processes and improve cognition.
I like it. You could create a super intense video game with all these components.
Yep. I mean, it is our plans, but putting all these things together will take us no less than 5 years until we're doing those type of multimodal interventions.
Wonderful. Well, thanks for dreaming big with us today, Adam, and talking about these big questions that are on your mind. And we've talked about a lot of fantastic aspects of your career as we've gone through our interview. And I want you to think back now on all the advice that you've received over the years. And I want you to pick one gem to share with our listeners today to pay it forward.
It depends. Obviously, advice varies at different stages of your career. I think a very valuable piece of advice I got when I was a young professor, when I just started out, which is a decade ago. Well, it's hard to take someone in your lab that is not maybe working hard enough or connecting with the research in a deep way. Maybe they're not super passionate about or inspired, and to turn them into that motivated, inspired, hardworking, high-performing person that you want them to be. I think a lot of people try to do that because it feels like it's the right thing to do, but it is exhausting and a time sink and often unsuccessful, and sometimes creates a spiral that exacerbates the situation. And so there is something to be said about, as a leader of a team, focusing your time on the people that are really stepping up. That might seem counterintuitive since those people are already doing really well. But what I have found is that frequently I put my time and attention to where the data and the effort is coming from. And people that are not giving it very often step up because of that, and they want to be part of that conversation. So I think it's not the approach that people take. They focus on the 1/3 of their team that needs the most help as opposed to their 2/3. I think a better approach is to really give attention to the stronger part of the team. And I know that's hard Darwinian way of going about life, but I've seen it work to the advantage of everyone on the team over my last 10 years as being the lead of a lab.
It's almost invoking that classical conditioning, rewarding the good behavior so that other people want to do well as well.
Yeah, exactly. And you only have so much time to invest when you have a large team. And so decisions have to be made, and it's a brutal one. It's really hard to do. And I don't think there's a right answer, and I think it depends on personalities, and obviously there are exceptions, of course. But figuring out how to inspire people is an age-old problem. And my approach to it is to just try to lead by example as much as I can and not focus on trying to figure out how to inspire someone that might have lost their way.
Great advice, Adam. Is there any other last piece of advice or a last note of inspiration that you would like to end our conversation on today?
I would say that science is a tricky business. It's hard to raise money. It's hard to do really rigorous work that takes years and then publish in the best journals. And sometimes that environment could lead people to become very conservative and sort of super iterative, where they're just taking that little baby step forward because it's the safest. And there's nothing wrong with that, and science needs that. But taking that big leap and being fearless, I think, is really an amazing thing to do, at least part of the time. And when it works, it's just really incredibly empowering. And you can do a lot of powerful and good things for our society if you're just not afraid to take that chance.
Well said, Adam. Listeners, definitely take this advice to heart. And Adam, can you tell our listeners now how they can reach out if they want to learn more about you and your work?
Yeah, so we have a couple of websites. One, a shortcut to, it has the full EDU name, but the quickest way to get onto it is gazzlab.com, so gazzlab.com. We have a lab for the Neuroscape, which is our high-tech gaming lab that shows a lot of the technology that we're building there, and that is neuroscapelab.com, so neuro, S-C-A-P-E, Neuroscape Lab, one word. And on Twitter, I don't tweet as much as I probably should.
Me too. I'm guilty.
At Adam Gazz, so very easy. Adam Gazz is sort of all of my social media handles. So that's the best way to follow what we're doing. We have a newsletter. We post our PDFs. I have a lot of lectures like TED Talks and others that are on our website that are all accessible.
Well, listeners, lots of options out there. Definitely check out more on what Adam is working on. Fantastic work. And Adam, thank you so much for joining us today and sharing a piece of your story.
My pleasure. Thanks for having me. It was a really fun interview.
Well, it was a delight to chat with you today. Listeners, thank you for joining us. We'll see you next time on another episode of People Behind the Science. Your voyage to the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to seeing you next time on People Behind the Science.